Now in this lecture, we are going to create stack using linked list. Now here we have linked list class like this. So this is a linked list class that we created in our single linked list section. So here inside this class, we have create single linked list method. We have insert in single linked list method, and we have traversal, which we are not going to use in this lecture, and we have search method, and this one also will not be used in this lecture. And then the next method is deletion of node, and this one we are going to use in our stack implementation. And then we have delete single linked list method, and this one also will not be used in our lecture over here. The reason that I kept this method over here is I just copied the single linked list method from the section of single linked list. So here I haven't done any modifications, so that's why this class remains the same. So what I'm going to do, I'm going to use this class inside stack creation when we are creating using linked list. Now here we have another class which is node class, and based on this node class we have created this linked list class over here. Now everything about these two classes was explained in our single linked list section, so if you have not watched that section, I advise you to go back and watch that section before continuing over here, because there we have implemented all functions of linked list, and here we are going to use them to implement stack. So let's get started. So here the first thing that I'm going to do, I'm going to create our stack class over here. So inside this stack file, I'm going to create stack class. So it's going to be like this: public class stack. Now inside this class, the first thing that we are going to do, as we said before, we are going to declare the linked list. So this linked list will be declared based on this linked list class over here. So it's going to be like this: linked list will be linked list. Then inside constructor, we are going to instantiate our linked list. So when we are instantiating this linked list over here, basically we are creating our stack. So inside constructor, I'm going to do like this: public stack. Here I'm going to instantiate this linked list over here. So it's going to be like this: linked list equals new linked list. So with this, we have successfully created our stack over here. So all we have to do, we have to create an instance of this class over here, and this will create a stack over here. So inside main class, if we open it like and write it like this: stack new stack equals new stack, then in this case we have successfully created our new stack over here. Now after creation of stack, the first thing that we have to do, we have to insert some elements over here. Now in case of stack, we are pushing the elements to the stack, so every time when we push the element to the stack, the element locates on the top of the previous element. So in this case, I'm going to create push method over here. So I'll put it like this: push method. So I will declare our push method like this. Now we know that in case of push method, it's not returning anything, so I'm going to put void and push, and it's going to take one parameter, which will be the type of integer, because our stack is the type of integer. Now here, the thing that we are going to do, we are going to call linked list insert method using index of 0, because when we put the index of 0, it's inserting element at the beginning of single linked list. Now, as you remember, when we are talking about push method in case of linked list in stack, we said that when we are pushing element to the stack, we are inserting elements at the beginning of linked list. Now, as you remember, inside linked list class, we have a method insert in linked list, and we have two parameters over here. The first parameter is node value, and the second parameter is location value. Now, if the location is 0, it means that we are inserting at the beginning of single linked list. So here, by default, inside stack, we are going to use location parameter 0. So what I'm going to do over here, I'm going to call linked list insert method with the value of that comes from parameter, because every time we are inserting the beginning, so this will be the value, and the parameter, location parameter, will be 0, because every time when we are pushing element to the stack, it's going to insert at the beginning of linked list. Now the reason for this is it is performing very fast, because when we are inserting an element at the beginning of linked list, it takes O one-time complexity, and when we are removing element from the beginning of linked list, it takes O one-time complexity. So that's why it's really recommended to insert elements at the beginning of linked list when we are implementing it in stack. Now after inserting this element, we are printing out to the console saying that inserted successfully. So I'm going to print out to the console like this: inserted value, I'm going to put value in stack. Now let's see how this is working in practice. So what I'm going to do, I'm going to call push method inside this for this stack that we created over here. So it's going to be push 1. Then I'm just going to copy it from here and put it over here. And one more time put it over here. So I'm going to put 2 and 3. Now if we run our code, now you see that it's printing out to the console 3 message. Inserted 1 in stack, so we have pushed first 1. Then inserted 2 in stack, so then we have pushed 2. And inserted 3 in stack, and then we have pushed 3 over here. Now push method works the way that we want. Now you might be interested what's the time and space complexity for this method over here. Now the time complexity is O1 because we said that when we are inserting an element at the beginning of single linked list, it takes O1 time complexity, so that's why this will take O1 time complexity, and this message also will take O1 time complexity. Now if we combine these complexities over here, we get O1 time complexity. Now the space complexity is also O1 because in this case we are just inserting an element at the beginning of linked list, so that's why pushing an element to the stack in case of linked list will take O1 space complexity. Now let's continue to the next method. Now before continuing to the pop method, I'm going to implement isEmpty method over here because isEmpty method will be used inside pop method, so that's why the next method will be isEmpty method. Now as you remember, when we are talking about isEmpty method in case of implementation using linked list, we said that if head points to the null, this means that our stack is empty because we don't have any element in our linked list. So that's why the isEmpty method will return boolean. So I'm going to put it like this, isEmpty. Then I'm going to check that if linked list had reference to the null, if linked list dot head is equal to null, in this case it means that we are going to return we don't have any element in our linked list, so this means that our stack is empty. Otherwise we are going to return false. If it is not referenced to head, it is referencing to something else, it means that we have nodes in our linked list, so this means that stack is not empty. Now let's use this method to see how this is working in case of the stack that we created over here. Now we have created a stack over here and we have inserted 3 elements to this stack over here. Now let's run this method to see that if this is working correct or not. So I'm going to put it isEmpty. So I'm going to create a variable over here which will be the type of boolean result and set result that comes from the empty method to this result, and then printing out this result to the console. Now if we run our code, now in this case you see that after inserting 3 elements it returns false, so this means that our stack is not empty. Now if we run this method, for example before this push methods over here, it's going to return true because in this case when we are creating a stack it is empty. So if we run our code, you see that first it returns true because when we are creating a stack it's empty, then we have inserted elements over here. So in this case our isEmpty method works the way that we want. Now let's see what's the time and space complexity for this method over here. Now we are going to start from the first line of code. So in the first line we are checking that if head points to the reference or not. So this will take O1 time complexity, then we are returning true, and this line of code also will take O1 time complexity, then we are returning false, and this line of code also will take O1 time complexity. Now if we combine all these complexities over here, it will take O1 time complexity. Now the space complexity is also O1 because in this case an extra space is not required to perform this operation. This is just if condition, so an extra memory is not required, so the space complexity is O1. Now with this we have completed isEmpty method. Now let's continue to create pop method. Now here I'm going to declare our pop method like this. So we know that pop method has to point to the value of the element that we are popping out from the stack, so that's why it's going to be like this. Public int pop, so it's not going to take any parameter, and it's going to return integer value. Now in this case the first thing that we are going to do, we are going to create an integer type of result variable, and we will set it to -1 because if we don't have any element in our stack, it's going to return -1 and it will say that the stack is empty. Now then after creating this variable, the first thing that I'm going to do, I'm going to check if this stack is empty, so it doesn't make sense to continue. So that's why here I'm going to print out to the console saying that the stack is empty. So here I'm going to put the message like this: the stack is empty, Otherwise, we are going to continue to pop out elements from the stack over here. So here, when we are popping element from the stack, we are removing the element from the beginning of linked list and we are returning that element as a return value. Now in this case, before removing it, we have to get that value. So I'm going to set that value to the result. So result will be equal to linked list dot head dot value, because in the head we have first node's value. That's why if you write it something like this, we are setting first node's value to the result over here. Then we are going to delete first node from the linked list. Now as you remember, when we are creating linked list class, we have created delete method over here. So this delete method takes one parameter, which is location. So if I put 0 as a location, then in this case it is going to delete the first element from the linked list. So that's why I'm going to call this method over here after setting the value to the result. I'm going to call this method like this: in linked list dot deletion of node with the parameter of 0, because when we put 0, it's going to delete first element from the linked list. Then at the end we are going to return result, because in result we have the elements that we are removing from this linked list over here. Basically it's returning the top element from stack, and at the same time it's deleting the top element from stack. Now let's see how this is working in practice. So inside main class, we have created a stack like this and we have pushed 3 elements to this stack over here. So I'm going to just delete this part from here, and instead of isEmpty method, I'm going to call pop method. So that's why the type of the result will be integer. So here I'm going to call pop method. Now as you see, we have first inserted 1, then 2, then 3. Now in this case 3 is the top element. So this means that if I run pop method, it has to return 3 over here, and 3 has to be removed from the stack. Now if you run our code, you'll see that first it's inserted 3 elements to the stack, then it's returning 3 over here. So this means that 3 removed from the stack and it's returned over here. Now if I run pop method one more time, so I'm going to just copy this code from over here and put it over here. So the variable will be the result 1. Now in this case, it has to return 2 because 3 is already removed by calling the pop method over here. Now when we call the second time the pop method, it has to return 2 over here because second top element is 2. Now you see that first it returns 3, then it returns 2. So our pop method works the way that we want. So our implementation works successfully. Now let's see what's the time complexity for this pop method over here. So as always, we are going to start from the first line of code. So in the first line, we have created result variable and set -1 to it. So this means that it will take O1 time complexity. Then in the if condition, we are printing that if it is empty, we are returning this message over here. Now isEmpty method takes O1 time complexity, and the returning message to the console also takes O1 time complexity. Now then we are accessing the head value of the linked list and setting it to result. So this assignment statement will take O1 time complexity. Then at the end, we are deleting element from the beginning of single linked list. Now we said that when we are deleting an element from single linked list, it takes O(n) time complexity, but when we are deleting an element from the beginning of single linked list, it takes O1 time complexity. So that's why this line of code over here will take O1 time complexity. Now at the end, we are returning results, so this one also will take O1 time complexity. Now if we combine all these complexities over here, we get O1 time complexity. Now the space complexity is also O1 because in this case, in each time we are deleting one element from the stack. So this is not space consuming operation, that's why it will take O1 space complexity. Now after finishing pop method, we are going to continue to the next method. Now the next method is pick method. So I'm going to declare our pick method over here. So we know that in case of stack, pick method returns on the top element and it's not deleting the top element. Now in case of pop method, we are deleting the top element and returning it, but in case of pick method, we are just returning the pop element without doing any deletion. So that's why it's going to be like this: public int, the return value will be the int because our stack is int. Then inside this method, we are going to check that if the stack is empty, we are going to return that the stack is empty. If it is not empty, we are going to return the head value from the linked list because head value is the top element in our stack over here. So I'm just going to copy this part of code from here, from the pop method, and put it inside pick method. So here this part is same. So after message we are going to return -1, because if the stack is empty, we have to return -1. Otherwise, we are going to return the head value of this linked list. Because in the first element of the linked list, we have the top element, so that's why it's returning head value over here. Now let's see how this is working in practice. So instead of pop method, I'm going to call twice pick method. So what I'm going to do, I'm just going to change these pops to picks and run our code. Now you see that in this case, it returns 3 twice because our top element is 3, and it returns 3 twice because in case of pick method, we are not deleting the element from the stack. So that's why it doesn't matter how many times we are calling pick method, it always will return top element without deleting it. Now let's see what's the time and space complexity for this method. So it's obvious that it is O1 because in this case we are just checking that if this is empty and we are returning message to the console and returning -1. So this part of code will take O1 time complexity. Now at the end, in the else condition, we are returning head value, and this part of code also will take O1 time complexity. So that's why the pick method in case of linked list implementation takes O1 time complexity. Now the space complexity is obviously O1 because in this case an extra space is not required because here we are just returning message or the value of head. So that's why space complexity is O1. Now then, finally, we are going to implement our last method. So the last method is delete method. Now we know that in case of stack, delete method deletes the stack from the memory. Now in case of linked list implementation, we said that when we are deleting stack, we are just setting the head value of the linked list to null, and with this, all nodes becomes eligible for garbage collection, and garbage collector comes and deletes that one from the memory. So that's why I'm going to declare our delete stack method like this. Delete stack. It will not take any parameter. And here, all we have to do, we are going to set linked list dot head to null, and I'm going to print out to the console saying that the stack is deleted. The stack is deleted. Now with this we have completed this method also. Now let's see how this is working also in practice. For this new stack over here, I'm going to call delete stack. Now after doing this, if we call our method, you'll see that it says that the stack is deleted. Now with this we have successfully implemented delete method for stack over here. Now the time complexity for this method is O1 because here all we are doing is we are just setting head value to null and printing out message to the console. So these 2 lines of code will take O1 time complexity. Now the time complexity for deleting stack takes O1 time complexity. Now the space complexity is O1 because here also we are not performing any space consuming operation. Now with this, we have come to the end of this lecture. So in this lecture, we have implemented all operations on stack using linked list. Now hopefully everything is clear about these methods over here. Now see you in the next lecture.